Well, good morning, everyone. It is early. I have class this week, and I wanted to hop on and talk to you about a trainer concept, or not a trainer concept, a some modifications we're making to one of our trainers that I think really adds a whole lot of features to it. So it is our standard trainer. Now, this is the video trainer. It's wired just that way I can grab it when you have a question and we can talk it out, but still they won't be wired. You're going to have to learn about syncing and sourcing, analog, 2 wire, 4 wire, 4 to 20 milliamps, all those fun things. But two items we added. First, we've added an encoder to the front of the fan. And initially, I was going to have two options of this. I was going to have an incremental option and I was going to have an IO-Link option. Because similarly, when I posted it initially, a lot of you are like, that IO-Link's going to be way too slow. And no, I only did one bench test, so I am saying this kind of just off of a singular observation, but I ran this and found that it gets about a 10 or 11 millisecond update rate, which is pretty outstanding considering that most of our IO usually has an RPI. Oh, well, it may, I guess now that I say that, it probably could get faster. I don't see a need to though, because it's coming over IO-Link and that has a 10 millisecond RPI. So we are seeing a change in this encoder value every 10 milliseconds. So outstanding performance on that. So I'm not even going to do the incremental option. It's just going to be IO-Link. But so what does that add to our trainer? First of all, we can do some really basic rate calculations. We can do a lot of, discovering, doing math, discovering ramp rates, discovering, lots of things, derivative calculations. Oh, speaking of derivatives, we can now do PID control with this. And I have tested the PID on the Micro 850. I've actually tested it with the PowerFlex 525, but I think we are going to scrap that one because we're going to scrap the incremental feature. And then, yeah, hopefully this evening we'll test it with the control logic. Actually, I did a small test with it and it seemed to work really well. So now we can really get in the weeds of learning about PIDs, learning, how to do auto tunes without, having any additional hardware. Now, speaking of the IO-Link, let's look at this side. And yeah, it's a little messy right now because this is the prototype. Oh, getting ready to drag my cord around. Got to spin the other way all the way around here. And yeah, so we've mounted the IO-Link, which we've had this option for a while, but the IO-Link mounts to the linear actuator. And this is a Turk Fin 20, and it's capable of Ethernet IP, Modbus TCP, and Profinet. So a super flexible IO-Link module that really has very minimal configuration to get you up and running, which is what I really liked about it. But so we'll have that, and then we have three sensors, probably the three most common sensors. So we have a photoelectric sensor, and this is an IO-Link photoelectric sensor. So we're actually getting distance data, and we can get some cool diagnostics features. And to show one that you can, and also just we see a little bit of difference in sensors, is this is a standard inductive prox that is going to IO-Link module, and this is a standard capacitive prox. So we get photoelectric, inductive, and capacitive, which really covers most of your sensors that you're going to see out there. But yeah, that comes on around to the IO-Link, goes over Ethernet. And I initially was going to make a nice pre-wired thing, but then I'm like, well, part of, I always stress you need to learn wiring. And when you come to my training class, so often you're like, yeah, I can't figure out how to wire a sensor. If I could get the sensor wired, then I could probably make this thing work. So I'm actually going to go probably to just a regular, probably 3-level terminal block right here, where you'll wire up your IO-Link. I'll make pre-linked cables probably and clean it up a little bit. But that way you can understand the wiring and understand how you're getting it to the IO-Link. Or since these two are standard sensors, we can also wire them directly to the PLC and directly to the PowerFlex so that we can actually, learn about regular discrete if you don't have IO-Link. So I really am excited about this option. Along with that is now we have the Siemens XC208 Ethernet switch, and this is an amazing Ethernet switch. And we're going to be talking about, oh, way too early this morning, Jeff? Oh, no, it's not too early. I got class. I have class the next 2 weeks. I'm running back-to-back classes. But yeah, so first of all, yes, people have already commented, why would I put a Siemens Ethernet switch on an Allen Bradley PLC? Because this is probably one of the most feature-rich switches that I've seen when I was looking for this. You know, as things are growing, everything is connected over Ethernet now. We've got to start doing better network management. Well, speaking of management, starting with no more unmanaged switches. So we're working on phasing those out and, going to more managed switches, but also on top of that, going to where we can talk about VLANs, and we can also talk about redundancy with the compact logics. It is a DLR or device ring type network, so we can do redundancy to this. It also does inter VLAN routing and a lot of cool other things that honestly I am just learning about, but this is something that a lot of people have asked for. So on the back, while we're here, it does have the Yamaha linear actuator, so we can learn motion control. Really cool feature that I finally finished the videos on. They're not edited yet. Is I have managed to make it where you can learn all the basic Studio 5000 motion instructions with this linear actuator. So we can learn about, MSO servos on, MSF servo offs, the motion exits moved, MAM, the MRP. We can learn all those basic instructions. And I got a little in the weeds in one of the videos talking about how we actually could learn about camming and everything. Now, we have a kinetics trainer that we built a few of. At that point, if you're doing some intense, motion applications, it might be time to do that. Yeah, Jade, it is 5:30. I have class this week, so I really just wanted to hop on quick. But yeah, so we can learn a lot about motion with this. We can learn a lot about scaling, all types of things. Now, we have a basic relay, and don't count that part out. That's something that we kind of probably look over too much. Is this is a really good trainer for learning basic electricity. Remember, yours doesn't come wired. I only have this one wired because when you ask me a question, I need to be able to answer it instead of worrying about wiring something. But you can learn about your basic seal and circuits. You can learn how to wire HOAs. You can learn all your real basic electricity with this trainer. And then it has a potentiometer and a 4 to 20 milliamp meter, so we can learn a lot about analog. And yeah, we're going to be talking some cybersecurity and some items like that. See, and then on the front, well, we have the HMI, so we can learn about making touchscreen programs, making operator interfaces. Also, this can do some basic data logging. We also have some videos coming out on ignition that we can really pull some real data and do some analytics and throw it up in the cloud and all those good things. We can learn AC. We can learn about three-phase motors. A lot of people don't realize this is a three-phase motor. So you can learn about three-phase motors. And even though this is a 120 volt powered trainer. So it does still plug into a wall outlet. But yeah, with the encoder, we're going to be able to do a lot of interesting process control exercises. And I guess the only thing I didn't mention is these two modules are not on the standard trainer. In fact, I kind of want to take them off of these, but the analog we do run through the PowerFlex, so you learn to wire your 4 to 20 milliamps and your 0 to 10s to the drive, and then we have to learn to get them over Ethernet. So another really interesting exercise, and I'm seeing a lot more of that now. You get like 4 digital inputs and a couple analog inputs on a drive, and so you'll see a lot of systems that are kind of grabbing some buttons and stuff and putting them over on that. But I just wanted to hop on this morning, and yeah, if you can tell, I'm really excited about this trainer because really I got playing with it and I was like, man, this really is going to be a feature-rich trainer. Arguably, we're doing the automation project from concept to reality series where we're building out that smart manufacturing cell, and I think, with the exception, well, actually no, I will I was getting ready to say with the exception of the robot, but really, if you can understand how to program this linear actuator, you can understand a pick and place or a robot. I'll say this trainer can almost build, you can learn most of the concepts that are in your typical system. So I'd love to give you your feedback on that. And I gotta go finish getting ready for class this week, but everybody have a good week and look forward to hear what you think.